see derivative of parametric function. Consider the equations x is equals to f of t and y is equals to a function g of t. These equations may imply a function relation between the variable x and y. Given the value of t in some domain of closed interval a, b, we can find x and y. For example, if x is equals to a cos of t and y is equals to a sin of t, then x square plus y square equals to a cos of t square of this one plus a sin of t square of this one, which is equals to a square cos square t plus a square sin square t. Now put a square common. So here cos square t plus sin square t, and value of cos square t plus sin square t is 1. So here x square plus y square is equals to a square. Represent the equation of circle of radius a with center at origin, and the domain of t is close interval 0 to twice of pi. It means t belongs to the interval close interval 0 to twice of pi. If two variables x and y are defined separately as function by an intermediating variable t, then that intermediating variable is known as parameter. So in this example, x is equals to a cos of t and y is equals to a sin of t. Here t is parameter. So we discuss the derivative of parametric functions. So theorem is, if x is equals to f of t, if x is equals to f of t and y is equals to g of t are differentiable function of t, so that y is differentiable function of x, and if dx by dt is not equals to 0, dy by dx is equals to dy by dt divided by dx by dt. Now for proof, given x is equals to f of t and y is equals to g of t, let delta t be small increment in t, then delta x and delta y are corresponding differentiable function of t. So we have limit delta t tends to 0, delta x divided by delta t is equals to dx by dt, and limit delta t tends to 0, delta y divided by delta t is equals to dy by dt equal as 1. Now we consider delta y by delta x is equals to, we divide numerator and denominator by delta t, and here considering delta x by delta t is not equals to 0, so we consider here this delta y by delta x equals to, we divide numerator and denominator by delta t, so therefore delta y by delta t divided by delta x by delta t. Now taking limit delta t tends to 0 on both sides. So here limit delta t tends to 0, delta y by delta x is equals to limit delta t tends to 0, delta y by delta t divided by delta x divided by delta t. Now here separate the limit. So therefore limit delta t tends to 0, delta y by delta x is equals to limit delta t tends to 0, delta y by delta t divided by limit delta t tends to 0, delta x divided by delta t. Now here delta t tends to 0, as x is a function of t, so therefore as delta t tends to 0, delta x also tends to 0, so we replace this limit by delta x tends to 0, so we have limit delta x tends to 0, delta y by delta x is equals to limit delta t tends to 0, delta y by delta t divided by limit delta t tends to 0, delta x divided by delta t. Now from equation 1, here this numerator can be written as dy by dt and denominator can be written as dx by dt. So therefore limit delta x tends to 0, delta y by delta x is equals to dy by dt divided by dx by dt. That is limit on RHS exists, and therefore limit on left hand side also exists and is divided by dx, and therefore dy by dx is equals to dy by dt divided by dx by dt, where this dx by dt is not equals to 0, and this is the theorem for the derivative of parametric function. Here t is parameter. Now examples for derivative of parametric function. Find the derivative if x is equals to at square, y is equals to twice of at square. to twice of 80 square. Now differentiate with respect to t. Here parameter is t. So we differentiate x and y with respect to t. So here derivative of x is dx by dt is equals to a derivative of t square is twice of t. So therefore dx by dt is equals to twice of 80. Y equals to twice of 80 square. Differentiate with respect to t. So derivative of y with respect to t is dy by dt is equals to twice of a, and derivative of t square is twice of t. So dy by dt is equals to 4a t, 2 to the 4. Now by the theorem of derivative of parametric function, dy by dx is equals to dy by dt divided by dx by dt. Now put the value of dx by dt and dy by dt. So therefore from 1 and 2, dy by dx is equals to, here dy by dt means 4at divided by dx by dt is twice of 80. So dt get cancel, a get cancel, 2 to the 4. So dy by dx is equals to 2. And is the required derivative. Now next example, x is equals to cos of log of t, y is equals to log of cos of t. So here given x is equals to cos of log of t. Differentiate with respect to t. So derivative of x with respect to t is dx by dt is equals to derivative of cos is minus of sine log of t into derivative of quantity other than x means log of t. So this is, so with respect to ddt of log of t. So minus of sine of log of t into derivative of log of t is 1 divided by t. So dx by dt is equals to minus of sine log of t divided by t, call as 1. Now y is equals to log of cos of t. So differentiate with respect to t. So derivative of y with respect to t is dy by dt is equals to derivative of log is 1 divided by cos of t into derivative of ddt of cos of t. So derivative of cos of t is minus sine of t. So therefore dy by dt is equals to minus of sine of t divided by cos of t, and sine of t divided by cos of t is tan t. So here dy by dt is equals to minus of tan t, call as 2. Now by the theorem, dy by dx is equals to dy by dt divided by dx by dt. Now put the value of dy by dt and dx by dt from 1 and 2. So therefore dy by dx is equals to minus of tan of t divided by minus of sine log of t divided by t. So transfer denominator t in numerator. It means dy by dx is equals to t tan of t divided by sine log of t. Now next example is x is equals to root 1 minus of t square and y is equals to sine inverse of t. So here given x is equals to root 1 minus of t square. So we differentiate with respect to t. So derivative of x with respect to t is dx by dt is equal to derivative of root means 1 divided by 2 root. Here quantity is 1 minus of t square into derivative of 1 minus of t square. So here derivative of 1 is 0 minus derivative of t square is twice of t divided by 2 root 1 minus of t square. Here 2 to get cancelled. So dx by dt is equals to minus of t divided by root 1 minus of t square, called as 1. Now secondly, y is equals to sine inverse of t. So we differentiate with respect to t. Now derivative of y with respect to t is dy by dt is equals to derivative of sine inverse of t means 1 divided by root 1 minus of t square, called as 2. Now by theorem, that is the derivative of parametric function dy by dx. So dy by dx is equals to dy by dt divided by dx by dt. Now from 1 and 2 we put the value of dy by dt and dx by dt. So dy by dx is equals to dy by dt means 1 divided by root 1 minus of t square divided by dx by dt means minus of t divided by root 1 minus of t square. So here root 1 minus of t square get cancelled. So dy by dx is equals to minus of 1 divided by t is the required solution. Now next example, x is equals to a theta plus sine theta and y is equals to a 1 minus of cos of theta. So here parameter is theta. So we have to differentiate x and y with parameter means with theta. So here x is equals to a theta plus sine of theta. So differentiate with respect to theta means dx by d theta is equals to a into derivative of theta with respect to theta means 1 plus derivative of sine of theta is cos of theta. So dx by d theta is equals to a into 1 plus cos of theta. Now secondly, y is equals to a into 1 minus of cos of theta. So here a derivative of 1 is 0 minus derivative of cos of theta means sine of theta. So here derivative dy by d theta equals to a. Here derivative of 1 is 0 minus derivative of cos of theta means minus sin of theta. Here differentiate with respect to theta. So divide by d theta is equals to a sin of theta called as 2. Again by the theorem derivative of parametric function. So here parameter is theta. So we can write divide by d theta divided by dx by d theta. Now from 1 and 2 we write here divide by d theta means a sin of theta divided by here a 1 plus cos of theta. So a get cancelled. Now the formula for sin theta means 2 sin theta cos theta. So here sin theta we write 2 sin of theta divided by 2 cos of theta divided by 2 divided by. Now formula for 1 plus cos theta 2 cos square theta divided by 2. So here 1 cos get cancelled. We are getting here sin theta by 2 divided by cos of theta divided by 2. So divide by dx is equal to sin divided by cos मुझे tan theta divided by 2. So is the required answer. So your next example is find the derivative of x is equals to sec square theta, y is equals to tan cube theta at theta is equals to pi by 3. Now here given x is equals to a sec square theta and y is equals to tan cube theta. Here x is sec square theta, y equals to tan cube theta. So here parameter is theta. So we differentiate x and y with respect to theta. So here x is equals to sec square theta differentiate with respect to theta. So derivative of x with respect to theta is dx by d theta is equal to the sec square means 2 sec theta into derivative of sec theta tan theta. So dx by d theta is equals to 2 sec square theta tan of theta all as 1. Now secondly y is equals to tan cube theta. So differentiate with respect to theta derivative of y with respect to theta is divided by d theta. Derivative of tan cube means 3 tan square theta into derivative of tan of theta is sec square theta all as 2. So from 1 and 2 by theorem divide by dx is equals to divide by d theta divided by dx by d theta. So therefore divide by dx is equals to 3 tan square theta sec square theta divided by 2 sec square theta tan of theta. So here sec square theta get cancelled, 1 tan theta get cancelled. So divide by dx is equals to 3 divided by 2 tan of theta. Now we are to find the value of derivative at theta is equals to pi by 3. So therefore at theta is equals to pi by 3 divided by dx is equals to 3 by 2 tan of pi by 3. Now here tan of pi by 3 means root 3. So therefore divide by dx at theta is equals to pi by 3 is equals to 3 root 3 divided by 2. And this is the required solution. Next is equals to t plus 1 divided by t, y is equals to 1 divided by t square at t is equals to 1 divided by 2. Now we are given here parameter is t, so we differentiate x and y with parameter t. So we are given first one is x is equals to t plus 1 divided by t. So differentiate with respect to t. So dx by dt is equals to derivative of t is 1 and derivative of 1 divided by t is minus of 1 divided by t square. So this can be written as t square minus of 1 divided by t square. This is value of dx by dt equal as 1. Now y equals to 1 divided by t square. So this can be written as t to the power minus of 2. So differentiate with respect to t. So derivative of y with respect to t is dy by dt is equals to derivative of this one. So here write down the power, subtract one power from power means minus of 2 t to the power minus of 2 minus of 1 means minus of 3. So this can be written as minus of 2 divided by t cube equal as 2. So we know dy by dx is equals to dy by dt divided by dx by dt. So from 1 and 2 we put the value of dy by dt and dx by dt. So here dy by dx is equals to dy by dt means minus of 2 divided by t cube divided by t square minus of 1 divided by t square. So here one will get cancelled. This is equals to minus of 2 divided by t into t square minus of 1. So this is the value of dy by dx. Now we have to find the value of derivative at t is equals to 1 by 2. So dy by dx at t is equals to 1 by 2 is equals to minus of 2 divided by 1 by 2 into 1 by 2 square minus of 1. So this is equals to minus of 2 divided by 1 by 2. Here 1 divided by 4 minus of 1. So dy by dx at t is equals to 1 divided by 2 is equals to minus of 2 divided by 1 by 2. Here this term is 1 minus of 4 divided by 4. So this is equals to minus of 2 divided by 1 by 2 into this one is minus of 3 divided by 4. So this is equals to minus of 2 divided by minus of 3 divided by 8. So this is 8 transferred to numerator. So 8 to the 16. So this can be written as 16 divided by 3. So this is the value of dy by dx at t is equals to 1 divided by 2.